Welcome to Mission Critical, the Harding America's content series that offers our global audience of engineers the details they need to make informed decisions and provide inspired solutions. Today's topic is hardwiring versus connectorization. Let's begin.
So hardwiring is the old traditional method where you're going to have just one run of cable that's going to be connecting between your cabinets and your subsystems, where it's going to go into the cabinet itself and then going into the individual terminal blocks. Connectorization is where you're going to take that run of cable and break it down into fragments. So where the individual wires that are terminated in the cabinet are only going to run to the edge of the cabinet, and then on the exterior of the cabinet, you'll have a whole separate cable that's easily disconnected or reconnected running between that cabinet or its subsystems. For hardwiring, that's going to be perfectly fine if that machine is going to be stationary and you're never going to have to disconnect it through the life cycle of that machine, right? But you're kind of going to be restricted if there's any changes in the market that are going to require, featurization. You're kind of restricted in that. If you want to disconnect or reconnect for testing or installation or any kind of maintenance in the future, connectorization is going to allow just a simple latching and unlatching. But on the other end, if there's hardwiring, if you need to do any of those activities, you're basically going to have to rebuild the entire machine. For the machine builder, their main concern up front is going to be the 30% savings on their hardware, right? But then when you transfer that off to the builders, they're actually going to be going in the machine, hardwiring everything individually. The real problem is going to be if they need to do frequent testing along the way, and again, going to extend the amount of time it's going to take to build that machine. And then fast forward, when they need to ship that machine, they're going to have to break it down again and then ship that over to the end user. And the end user is really who's going to bear the brunt of all those issues with hardwiring. Then eventually there's going to be some maintenance cycles where these end users are going to have their own professional electricians that they're probably going to be paying good money for. But even they are not going to be as experienced as the builders in dealing with some of those issues or as familiar with those machines. At the end of the day, connectorization, even though there's an upfront hardware cost, there's also an upfront a little bit more setup time that would be necessary to connect and terminate some of those connectors. But once that's done, and the only thing you need to do to break things down is to literally just plug something in, snap a lever, and that's it. Personally, I have had to build a CNC machine before where it was pretty much IKEA style. Everything had to be both built from all of the sheet metal going all the way down to the individual wiring, the terminating, everything. I had to literally climb into that machine anytime I needed to troubleshoot something, figure out why something wasn't moving correctly, but especially with wiring, I felt like I was going to get carpal tunnel. I was cramped in between these little sections, trying to get these 90-degree angle wrenches in just the right way. And if you're in a facility that doesn't have any air conditioning and you're sitting in this confined space, you can get really frustrated really quick, and it's really not fun, right? With a connector, and the builder just had everything already set up and terminated in there. All I would need to do is snap in a cable. I would be eternally grateful and would be more than happy to pay that little extra cost to save, again, precious time. Quick disconnect would be recommended over hardwiring with pretty much any kind of machine or system that's going to have separated cabinets or different components, where you're going to have a run of cable or conduit running between them, right? At some point, those are going to need to be broken down, and just having a connector to literally just snap in place is going to be so much easier than having to run the cable in, run it to its individual places. Taking that up a notch, if you're combining power, data, signal, pneumatics, everything, and it's going to each of the different subsystems, it's going to be a lot easier to combine them into a modularized connector where you would have just one connection instead of having many different ones. So there's a manufacturer of large material handling cranes where they need to take each one apart for shipment to their customer, and then reassembled anytime it needs to be broken down. So transitioning from hardwiring to modular connectors reduce the amount of time to build and reassemble from weeks down to a mere 3 to 4 hours. And again, not forgetting about the fact that when you are hardwiring, if there's any kind of issues, instead of just having a cable the plug, you're having to go back into those cabinets, go back into those components, and individually figure out what exactly didn't get wired correctly. And again, that's going to expand your overall time and labor. I worked with the company and helped them with the design for a 3D printer that would print houses. So it'd print the concrete for the foundation. But the problem was they had many different segments, right? So they're going to have multiple different stacks where, they're going to have pillars moving on wheels. So they're going to have multiple different motors running different, X, Y, and Z axes. And of course, like the sprue coming down as well. So with each point, they were having separate connectors for their power for each motor, for the data that's going to be running between the motors, back to the controllers, and any kind of signal connections in between. So again, each one was not just a different connector, a different manufacturer. And when it came time for the installers to work with that, it was taking them a significant amount of time every time they needed to lay down that house and move the track somewhere else, right? So they came to us to come up with a new design where we could take all those different connectors and for each different run, just make one modularized connector with our HAN module connectors, where we could combine our power, our data, and our signal. With hardwiring, none of this would have been possible, but with HAN Modular series, we could take all of those connectors and put them down into one. So one that I feel needs to be talked about a lot is HAN rear fit. So previously, when you have your cabinet manufacturers, the cable assemblies are often going to be done somewhere else, right? So when they get brought in to the cabinet manufacturers, they still need to take those cable harnesses and then terminate them, because previously the connectors are going to be on the other side of the cabinet and you need to feed the cables through the rear. So with a rear fit, you can have your cable assembly manufacturers do all the terminations and then actually put them into the connectors themselves. So you bring the cables over to the cabinet manufacturers and all they have to do is just snap it right into the rear of the cabinet and everything's good to go. If I had one piece of advice for considering hardwiring versus connectorization, it would be to map out every single possible expense that would need to be taken down the road. Not just the hardware, but considering the installation, to shipping to the customer, to maintenance, any kind of testing that needs to be done. Hardwiring up front may save you about 30% just on the hardware itself, but then what you have to consider is any changes that need to be made all the way down the line.
For more details on the benefits of installing Harding connectors versus hardwiring, contact us today.